and then generates. Let's talk a little bit about Model Context Protocol. So this is essentially a USB for AI. The idea is that it is a universal adapter that lets any assistant, whatever model family, connect to any data source interoperably. Now, when I say USB, a while back, you had so many different types of USBs. You had like a USB 1, you had a USB 2, you had a USB A, a USB B. I don't actually know if this one's real, but you had like hundreds of different types of USB configurations, basically hundreds of different cables. And then eventually somebody made a USB-C, and they realized that this was just like the superior format. And then they made either regulations, depending on where you live, or just heavily incentivize the market to just produce USB-Cs. Because USB-Cs, if we all just standardize to one adapter, means that like I could just buy any device and then I could just slot that into any other device and it would just work. I don't have to carry around 20 different types of cables. I just know that this sort of adapter function is just going to make everything work, and it's going to be super easy and more convenient. That's essentially just what MCP is. We're just doing that for our AI agents. This was introduced by Anthropic back in November 2024. It's a standardized way for AI assistants to connect to any external data and tools. And this isn't just Claude, to be clear. They just made this for everybody. So this works with, like the OpenAI family of models. This works with the Gemini family of models. The whole idea is it just eliminates the need for those custom USBs for every connection. Just a universal translator. It's like, imagine there was some language that, anybody on planet Earth could speak. And, when you meet a person who doesn't speak the other language that you speak, you just all use the same language. It's Esperanto or whatever, but it's for, AI agents. That's basically it. There are two main pieces to understand. There are MCP clients on one hand, and then there are MCP servers on the other hand. So, these clients are basically our AI apps. So these are our things like anti-gravity. These are our VS codes. And these are also things like, Claude Desktop. These are things like, ChatGPT. And basically what these are is, you remember how earlier in the course I said that chats are just like the interfaces that agents are using right now. They're sort of borrowing them because we don't have a better interface. Well, that's essentially all a client is. It's just an interface. So the client is the tool that houses the agent, right? It's the shell around it. And what this does is it connects to servers. And these servers are based on specific tools. So for instance, there is an Apify MCP server. In addition to an Apify MCP, there's like an Apollo MCP. There is a, Google Drive MCP. There's a Sheets MCP. And the point is, whatever client you're using at the time, so maybe anti-gravity in this case, just calls the specific MCP whose configuration files you include in your workspace. So in anti-gravity, I might have, an Apify MCP, Drive MCP, and Sheets MCP. And then what I do is I just say, hey, can you, look at my drive for whatever file and then turn that into a big CSV? And then can you feed that CSV into Apify? And, assuming that these three MCPs are good, because there's a lot of quality variance in MCPs right now, it can actually do what you want it to do. You can also store high-level directives that explain how to chain these together even more in-depthly and more reliably. And then the MCPs are essentially just your execution scripts. Right now, there are three main ways that MCP servers communicate with MCP clients. There are resources, which are structured data like documents, code, database records, and so on and so forth. Then there are tools, which are functions that your agent can call. These are analogous to execution scripts on our end. And then there are prompts, which are basically just like system prompts for specific things. They guide how the model should interact with a specific server. Hey, you should use this execution script when you want to do this function. Hey, you should call this resource. You shouldn't paginate all of them. You should only call the first 50 lines. This just is like high-level instructions that help the model do things more reliably. The whole idea of MCP is really just to make the entire internet web accessible to our agents. Every tool gets its own MCP server. What your agent does is it only loads the ones that you absolutely need. This means you never have to build custom tools from scratch, though I think it is pretty easy and pretty great to get yourself that functionality. And you get to give your agent breadth out of the box with very little effort on your part. In addition, you can also build your own custom MCP servers. The value here is not only are you going to have your own agent use it, of course, but you could share it with other people. And by sharing it with other people, you can either ask them to either pay you or something to build the MCP server, or, let's say you're an API that builds an MCP server around your function. You can make things more accessible and then increase your company revenues. So it's very, very easy to build these things with AI assistants. When MCP came out, it was very difficult, but now it's super easy. I actually built one in 10 minutes the other day. I never read any MCP documentation, and it did something really cool for me, which I may talk about in a future video. This means you can create specialized tools for specific workflow needs anytime that you want. And then if other people within, let's say, your organization want to use this or whatever, you just share the MCP server. It's always going to work the same out of the box. Because it's the same server, now there are multiple people that can iterate and improve it, not just you. So the main question I get at this point is, why don't we just use MCP for everything? Sounds great, right? Maybe we should. Well, the reason why is because MCP takes a lot of tokens. And the more context the model deals with, the dumber it gets. If you fed in the exact same prompt to two models, except prompt 1 said what you wanted it to say in, 10 words, and prompt 2 said the exact same thing, but it wrote it really inefficiently and made it really, 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 really long, the model would almost always perform better here. Maybe this would have a 99% success rate, whereas this would have an 85% success rate or something. What I mean to say is there's a very strong relationship between token count in context and then performance. And this is improving as models get more intelligent, but essentially, performance as tokens go longer and longer and longer in the context almost always necessarily will decline. It's not exactly like this because usually when you provide more context, it's actually a little like bump until you get to a certain point and then it starts declining, because it's like here we didn't really provide enough information for the model to know what's going on, whereas here maybe we provided a bunch of examples or whatever, which is why it does better. But inevitably, the longer that you add a bunch of information that isn't relevant to your task, the more tokens that you have in that prompt, the crappier your outputs are going to be. And the issue with MCP is it actually loads pretty much all of its available functions into your agent's context window. Now, there are some developments that are fixing this. These are like at runtime MCP servers where your AI just makes an intelligent determination about which MCP servers to load and stuff like this. But MCP as a framework is still pretty new, and a lot of the MCP servers out there are pretty crappy. So regardless, we're loading a ton of tokens into a context window. Every function will have a name, they'll have a description, there'll also be a schema. This will be a few hundred tokens usually. And what that means is if you connect 5 servers, and every server has 10 tools. So like if you connected to the Drive server and then the Drive server had, get file. Okay, this is one of the functions or execution scripts. And it has read file. It has share file, and so on and so forth, right? Every single one of these would have a name, description, schema, name, description, schema, name, description, schema. We're getting really high up in the tokens already, right? If you have 300 tokens per definition, even 5 servers with 10 tools each means 15,000 tokens. And that's before you've done anything. So it's like you're already on that graph that I showed you guys earlier. If this is your performance when your token count is really low, you're probably already like down over here. You have some loss in percentage, which is just ultimately not efficient for business purposes. And you're probably wondering like, well, Nick, how bad is it really? What I want to do here is I just want to show you a quick example on some older models. And obviously keep in mind that in order for us to do research on things, they necessarily have had to have been out for a while. But older models and how their accuracy on tasks scales with the number of documents in the input context. So number of documents in the input context is basically equivalent to tokens in this way. So just call the number, one document in this case is probably equal to like 1,000 tokens or something like that. So as we see here at the very beginning, when the context is quite small and we only have 5 documents in the input context, this model here, GPT 3.5 Turbo 16K, performs very well. It performs maybe somewhere around 75% or so. The second we double that, accuracy is now to slightly over 65%. We double that again, and now it's almost down to 60%. And then if we 1.5x that, now it's like somewhere between 50 and 60%. So performance here really drops off extraordinarily quickly. And so to make a long story short, the reason why this happens is really similar to what I showed you guys earlier on in a demo, where like if you just have one token and then you have 3 potential tokens here, basically every single time you are forced to compute like the next token in a sequence, the total variance of the things that you could be generating just kind of go through the roof. And so that's what's occurring here. In order for, this model to somehow know that the right answer is over here, Obviously, it needs to somehow maintain some degree of accuracy and coherence, and that just becomes less and less and less and less likely the more tokens that you generate. Now, obviously, it doesn't happen this quickly. It happens over the course of many thousands of tokens nowadays. But back in the day when I was working with just the base vanilla GPT-2, the output quality was super sensitive to the number of tokens in the input prompt. Like if you added an additional 5 tokens, and those tokens were not very high quality tokens, they didn't really add a lot of value, like accuracy would plunge off a cliff. Screw documents here. Pretend like we're just talking number of tokens. At 5, it might be 70, but at 10, it would literally jump down and so on and so forth. So anytime you try and get to any reasonable answer, you're already working super below, total accuracy limits. Here's another example of memory retrieval accuracy. So basically, if there is some token buried super deep in the context of, a model that's doing 2,048,000 context window, it forgets it, when there are only 30,000 tokens in the prompt or whatever, it sees and finds it like 100% of the time. But if there are, 2 million, it'll actually forget about that a massive chunk of the time. And it won't even realize like that there is a token within its context. Basically, its ability to retrieve things from its memory, intermediate memory in this case, which is just the chat and the prompt, plummets. Finally, you could see here a needle in the haystack sort of example, very similar to what we were talking about earlier. But basically, as the number of tokens goes up, you see a massive decrease in just the model's ability to meaningfully keep track of things. And this is just sort of the way that intelligence works, right? The more things we're trying to juggle and keep in our head simultaneously, the higher the likelihood that we're going to forget any one of them. So as a demonstrative example, let's say I wanted my agent to write me an absolutely beautiful poem all about the meaning of life and our place in the universe. I say I'm a big fan of Maya Angelou, and Pablo Neruda is wonderful as well. Please make this short, but also punchy and very beautiful. If you think about it logically, like this prompt right here is a certain number of tokens, and I can count that here. I'm using a service called wordcounter.net. It doesn't count tokens, it counts words. But if you want the number of tokens, you basically just grab the number of words, then you multiply it by, 1 divided by 0.7 approximately. If I do that math, this is somewhere on the order of like 67 tokens. But I want you to look really, really closely at what I just wrote here. Are all of these words required in order to get the model to do something for us? Like, what is the information density of this sentence? Hello, is that required? Probably not, right? I could probably realistically remove that. Could. It's kind of a long way to say can. Can you? It's kind of a long way to just tell it to write something. So write me an absolutely beautiful. Do I need that? No. Write me a beautiful poem all about the meaning of life and our place in the universe. I say, emulate Maya Angelou, Pablo Neruda. Short, punchy, and I don't actually need to say very beautiful because I just said so earlier up here. Now, if you compare what I just wrote initially at 47 words to what I wrote here at 22 words, notice how I basically said the exact same thing I did in the first prompt, just in terms of the actual like pure information density. I just did it in less than half of the words. So now instead of 67 tokens, this is probably somewhere right around like, 28 tokens or something like that. What that means, walking back to our example, is you can realistically significantly improve the ultimate quality of an output just by refactoring the sentences that you feed into a prompt. Instead of, hello, could you write me an absolutely beautiful poem all about the meaning of life or whatever, I could create a new prompt instance, and then I could just say the exact same thing. And instead of me doing this on, 2 lines or something like that, I could do this on 1 line. And although it is very difficult to determine the quality of a poem quantitatively, what is occurring statistically is the quality of this poem over here will be better than the quality of this poem over here. The reason why is I just wrote it in a shorter, sort of punchier way. So as opposed to, if you think about this graph, quality and then the prompt length, as opposed to me being somewhere over here, like in this example, realistically, this example, I'm probably somewhere over here, right? So the reason I'm showing you this is because this is exactly what models are actually doing under the hood. Instead of writing in like laborious, long sort of ways, what they are doing is they're actually compacting the words that you are saying into as high an information density summary of your prompt as humanly possible. And they have a couple of strategies to do this. I don't know if you guys have seen like reasoning tokens, but the way that reasoning occurs here is it's actually done like a very high information density way. They actually specifically have trained the model to write in a way that is shorter on tokens as opposed to longer. If you look at other models out there, like GPT OSS 20 bill, for instance, or maybe 120 bill, these are open source models that OpenAI released a little while ago. You'll notice when you expand the reasoning tokens a very peculiar thing. It writes super short. It says, need to define X, but also Y, but maybe Z. And you're like, what the heck's going on? This is like an alien, really short form way of writing. Well, the reason why it's writing that way is because it's just much higher information density. And the higher the informational content in your prompt per token, the ultimate better response you are going to get. Another strategy that models will use is they will compact, okay? And what I mean by this is basically every time you feed in any prompt to a model, what it's also doing is it's going back and feeding in every message that you and it have ever sent to each other in the same chain. So what compaction is basically just you take the entire history of your prompt and then you just summarize it. Summarize everything we've talked about so far. So now I'm just going to have it summarize it all into a very succinct message. And then the way that compaction works is once we hit a certain token amount, which could be, 50% of the total number of tokens allotted or whatever, this summary is then fed into the next instance of the model. And so now, a future instance of, in this case, Claude Code would have access to more or less the full summary. Sure, we'll miss some details, but a lot of those details aren't really that consequential or important anyway. Think of how many fewer tokens this is than literally my entire conversation history from start to finish. Another big issue is when your agent calls an MCP tool directly, the entire response goes into the context. So if I wanted to pull a document from Google Drive, for instance, I would actually then have to store the entire thing in my context, at least the way models are right now. If I wanted to query a Google Sheet for like 10 rows or something, let's say all 10 rows had like 20 columns each. Well, now I have 200 additional cells within my context, meaning that your agent can hit the context ceiling really fast. It can burn a ton of money and so on and so forth when you use generalized MCP tools, not tools that you build yourself, but ones that other people build for you without really optimizing the process. Last thing I'm going to note on this is not all MCP servers are created equal. A lot of servers were rushed to market to capitalize on the hype. I know a couple just off the top of my head that are just super poor. They don't return like any good error codes. They don't even interact with the APIs correctly. And tons of people are unfortunately struggling because of that. Some good examples are Perplexities and N8N servers, but some really bad examples list too. I'm not going to name the names, but some are a complete joke. In general, you will know when you start interacting with an MCP server, just going to flag a bunch of errors. Your model's just going to be dumb as hell. You could tell pretty quick. All right, so let me show you how easy it is to connect the Google Drive MCP server. We've already done a little bit of MCP. I've obviously wanted to tease that throughout the course to keep you guys interested and engaged. But this time I'm actually going to do a full comprehensive walkthrough on how to do it. We're going to connect this to our agent, and then we're going to use it to perform a really simple operation. I just want you to notice how seamless the integration is once it's set up. I don't actually have to even like set up the directive or the script or anything. I can just communicate with it in plain language, and it can go in and call the appropriate tools for me. Let's talk MCPs. Now, as I've talked about, Model Context Protocol servers differ in their quality. Some were made pretty hastily, others were made very carefully and are very high quality. But because of this, you do have to be a little bit careful and be open to doing some trial and error when it comes to adding your own MCPs. Regardless, I'm going to show you guys how simple and easy it is to do. First of all, there are tools and websites out there like mcpmarket.com and mcpservers.org whose sole job it is to basically categorize and then list all of the good MCP features out there. So as you can see, there's an MCP for Trigger Dev, MCP for OpenSpec, Fast API, Pipedream, PAL. And these, on these tools anyway, are basically rated based off of their quality. So the higher up, the better, right? So if you want the ability to automate browser interactions for large language models using Playwright, this is the MCP for you. If you want Chrome dev tools, this is the MCP model for you. If you want to automate, Serena specifically, then this is the one for you, and so on and so on and so forth. What I want to do in this video is show you just how easy it is to set one up. You guys have already seen me do this for ClickUp, although that wasn't the point of the tutorial. What I'm going to do in this demo is just be a lot more specific about it. So simplest and easiest way to get up and running with an MCP is just to ask your agent. So I'm just going to say, hey, I want to set up a Gmail MCP so that I can send emails on demand from my email address. And then I'm going to give it some details, just that it knows that, this is like a Google Workspace sort of address. And let's see what it does. First, it's going to look and see whether or not there's some email MCP already. It's probably not going to find it. It really does help to open up these thinking modules. So now it's going to say, hey, I see you've already set up an SMTP email for this email address, but instead, here are two approaches. First, you can do quick SMTP. Second, you could do the Gmail MCP. So obviously, I want to do Gmail MCP. Let's do the Gmail MCP. I want you to do everything you can for me. Typically, models will give you instructions and stuff like this, but it's much better just to have them do it all for you. So anytime you don't really know what to do, or it's laborious or involved, just see how much the model can do for you. And that's what it is currently doing. Okay, cool. And this actually ended up finding a previous OAuth instance somewhere on my computer. I should note it was not in this folder. I just asked it to get up and going. It's running into some issues here because I haven't actually done this for this MCP before, which is understandable. Now it's going to add some to my Claude config. Okay, now it's asking me to sign in, so I'm going to sign in right over here. Cool, says the authentication successful. We can now close this window. Okay, so now I just need to restart Claude Code. Okay. Just going to go MCP or manage MCPs. See that I now have my Gmail MCP connected. And now I can just say, hey, send an email to nicholas@gmail.com saying what's up. Boom, just sent me the email. Fantastic. That was easy. Okay, that's cool. Now that we've sent the email, obviously we have to talk about how to set up your own MCP servers, which is way cooler. So how do you actually go about this process? Well, I didn't actually know until quite recently. I just asked how would I create my own MCP server, and now it's giving me a bunch of knowledge. Here's how to create your own server using Python. So hypothetically, just for the purposes of this demonstration, I want to set up a really simple MCP, one that just does something really straightforward. Just reads my website, maybe it has some information about my website, and then it just like returns information about it. So I said, create a simple custom MCP server whose sole job it is to interact with this website, www.leftclick.ai. Now, in case you guys didn't know, leftclick.ai is my business. We are the definitive AI growth partner for fast-moving B2B companies. Essentially what we do is we build outbound growth engines that supplement AI to do things like personalize the emails, find leads, and so on and so forth. I talk about it a lot on my channel. And so literally all I want this MCP to do is basically just to be a resource for this website. I want people to be able to download it and then just be like, hey, tell me about LeftClick, and I want it to call the MCP. Is that something you need? No, obviously not. But you don't need MCPs in general. MCPs are just convenient, nice little wrappers around functions. Moving back to Claude Code here, you can see that it now created an MCP-servers folder. And what it's doing next is it'll write the server Python code. I have no idea what that Python code looks like. After that, it'll create some TOML for dependencies before providing some registration instructions for me. Okay, so it looks like it just finished. Creates a server that exposes 5 tools: get_company overview, get services, get booking link, get case studies, and search site. So that's pretty easy. It's saying, hey, do you want to register with Claude Code? I'll just say, great. Sounds good. Register. It'll go through the rest of that process for me. Okay, so now I'm going to do a new instance of Claude Code again. I'm going to go /MCP status. It's now loading my servers, and you can see now we have the LeftClick server available. So go to bypass permissions, and then I'll say, tell me about LeftClick. Now, what occurs when this happens is because we have access to the MCP data, it'll actually find that and then get me information about it. So that's what's happening right here. We called the MCP server as opposed to doing something else. Maybe I'll say, what's the booking link? The reason I'm asking this is because I saw there was a booking link feature. So it's going to call the get booking link function. Here it is, leftclick.ai, book a call to schedule a complimentary 30-minute discovery call. Now, in my case, I don't think I actually have a calendar, which is why it just gave me the thing and then it told me where to find it. But hopefully it's clear. You can build your own MCP servers super easily. So why build your own MCP servers to begin with? Well, generally speaking, like I probably wouldn't put together MCP servers for most things these days unless I wanted to share them with others. So like a creator building an MCP server for all of his followers to use, that's a pretty good option. And so maybe if there's something cool that, I want to share with you guys, I might do that and then make it publicly available. But aside from that, like, why would you build an MCP server instead of maybe using Cloud Skills or Doe? And I've had a lot of people ask me this, Nick, why don't you recommend MCP more often and so on and so forth? And the reason why is it's just not really required. MCP is positive insofar that it standardizes the ability to call tools and whatnot, but it's also negative insofar that it loads a ton into context. Like, what you're not seeing here is how many tokens that I am essentially consuming by having this MCP server. If I go / and then write the word context, you'll see that it actually includes a bunch of information about my context usage. And so basically the entire conversation we've had so far, I've used 1.4% in the system prompt, which is just the Claude.md, 7.4% in my system tools, which is just something I don't have control over. And you'll see that there's 8.2% of my entire context window dedicated just to MCP tools. The rest of the stuff, 0.6%, are my messages. And so what's really, really kind of annoying is that this thing is basically filled up about half of my entire context window. And really, I just have like a bunch of really simple tools. Left click at company overview, Gmail, send email. This is eating up a ton of my total token space, if you think about it. The left click server itself is almost what? I guess that's like 3,000 or so, over 3,000, 3,300 or something like that of my tokens. And, these tokens aren't free. I spend money to use these tokens. I also, obviously, every time I make a message and, have some output, the number of tokens in my prompt does affect the output quality, which we're going to talk about later. So for the most part, I don't actually recommend using MCPs unless it's something hyper standardized or unless it's like a one-click thing. And unless, you're building one that you want to, share maybe with your team or maybe with like a group of people. All right, so now let's talk about building the workflows. I built a bunch of workflows for you throughout various demos, but I now want to provide you guys a systematic approach to be able to do so yourself really easily and really straightforwardly. First, major principle. Everything begins and ends with your system prompt. That system prompt, as we know, is typically called Agents MD, Claude MD, Gemini MD, or Cursor MD. And there are many more naming conventions. I'm not going to cover them all. The name basically just needs to match whatever your IDE or agent looks for. And the content should be identical regardless of how you call it. Now for Do specifically, I'll show you guys exactly what mine looks like in a sec. This system prompt, or Agents MD, or Claude MD, or whatever, is basically just a supercharged prompt. When you communicate with ChatGPT in your window or in your browser and you say, hey, I want you to do whatever for me, that's a pretty short prompt. This one is basically a prompt that's inserted every time, and it's just super, super long, super intense, super comprehensive, and it covers more or less all of the edge cases and ideas that you want the model to have. It should explain your framework. It should also explain your thinking, what you want it to do at every step, and then more. This is how you customize your agent, essentially, so it's not just a cookie-cutter vanilla agent that functions the same for everybody else. The prompt right now is kind of the moat. Now, I do recommend you to copy and paste mine because it's just like out of the box pretty good, but there's some important things I'd like you guys to make sure to include, regardless of whether you're using mine or whether you guys are using somebody else's. The first is you should explain the framework. So whatever framework you're using, whether you are using Do or Claude Skills, you should actually explain that to the model. You should tell them where the resources are. Hey, directives are in the /directives folder. Hey, you should use .tmp if you want to store temporary files. Make sure to delete temporary files after you're done. I also find a lot of success in explaining the rationale behind the framework. It reduces error rates significantly. So I don't just say, hey, you're using the Do framework. I say, hey, right now, as a large language model, the probability that you can do things completely on your own without any framework is pretty low. Because of that, I'm using a framework called Directive Orchestration Execution. Here's how it works. Directives store whatever. Orchestration is you. Execution does whatever. By using this framework, you significantly reduce your error rates and blah, blah, blah. Here's why you should do this. Right? We actually convince the model. We almost have to get like buy-in from the model. When you get buy-in from the model, the resulting outputs are a lot higher quality. The second thing you should include is an explanation of self-annealing. Now, I'm kind of cheating here because I haven't actually got to this point, but bear with me. Self-annealing is the process of the model fixing its own mistakes without coming to you first. So rather than just break like an old school automation, self-annealing means if there's an error, you then feed that error into the model then reasons, and then it solves, and then finally updates so that it doesn't run into that problem the next time. In a nutshell, self-annealing allows the models to become more resilient. It doesn't just get back to working. And every time something breaks, it's a feature, not a bug, because it reveals weak points in your flow that you didn't even know existed. I'm going to tell you all about self-annealing and go really in depth with like system prompts and stuff like that later on, but for now, it's sufficient that you just know what it is. The third thing you need to include is you need to include a sense of autonomy. What do I mean by this? Well, I let the model know that, hey, my goal is for you to run autonomously without me. You are an agentic workflow. I say you should test each system on its own, you should identify mistakes on your own, and you should loop repeatedly until you make it work. I also say, hey, be careful when you're sending API calls or consuming my tokens for testing reasons. And then I say, hey man, this is really just a rule that says come to me only if you absolutely need to. I don't want you to come to me unless you are 100% confident that you cannot solve this thing without my human input. And that's very, very rare. When you do this, your model gets significantly more autonomous and you really change it from like this a co-builder programming thing into like a co-worker and a co-employee. At the end of the day, directives and execution scripts are basically living documents. So if there's an error or constraint that you guys find, you should instruct your agent to update them. Cool, so talking a little bit more about building, if you have SOPs, you're actually already halfway to having strong agentic workflows. All you really do is you just open your IDE, you drag your existing SOP document from your knowledge base or your company PDF or your company OneDrive or Google Drive into your workspace. You just say, hey, I just uploaded a file into the workspace. Could you turn it into a directive and build the execution scripts to make it happen? Now, if it's a really simple SOP, let's say something that doesn't even need an execution script necessarily, it's just like an AI prompt thing, it'll just do it, and it'll do it like really quickly. If it's a complex one, it may ask you to verify its approach. Hey, here's some ideas that I have. What do you think I should do? Okay, yeah, let's pick the first one. Let's proceed. When the agent does this, it'll create the directive in /directives. It'll build whatever scripts are needed and then store them in executions. And then if it doesn't have API tokens or whatever, it'll just ask you to add them to an env. This works really well because SOPs are literally already directives. They contain everything the agent needs: the goals, the steps, the inputs, outputs, and edge cases, if yours are written correctly. All you're doing is you're just translating your human readable documents into another human readable document in the form of directives. You're not really getting the agent to come up with anything new. It's just reformatting and translating into a more token efficient format. All you're really doing is converting a recipe into a format that some sort of robot chef can follow. You're basically programming this thing. If your SOPs aren't very good, believe it or not, this is actually an opportunity to make them better. Because your agent, knowing that it does not have everything that it needs in order to do the task, will ask clarifying questions. This will force you, as a systems engineer, to resolve ambiguities that a human being might just figure it out without explicitly having to write. The resulting directive ends up being a lot better than the original SOP a lot of the time, and it means that your messy docs become an opportunity to actually clean up your processes and become a clearer company. I think that's really underrated, but companies in general tend to bury the lead a lot of the time. They don't actually make explicit or verbalize all of the knowledge within the business. It's like, oh, just ask Pete for whatever. Send an email to this person. Your agent will say, well, who the heck is that? And why does that matter? Right? Can we just include the information that we need in order to do it now? If you have a big wait step or something, it'll be like, okay, to be clear, why do you want me to wait? What is the purpose of this? And so the very building process itself can actually help significantly upgrade your business. Now, let's say you have no documentation. Well, if you don't have any pre-existing documentation or SOPs, no problem. We can still make this work. What you do is you begin with some very basic bullet points that describe your ideas surrounding the agent. I use really plain conversational language. I will literally write down what I want to do as if I'm explaining it to a colleague. I have a bunch of people in my team. A lot of the time, this is messages that I would have sent to them. So sometimes I literally just go into Slack and I say, hey, I want you to do X, Y, and Z. It should be this, it should be that, it should be that. After I'm done explaining it like I'd explain it to a colleague, I then just copy and paste it into my agent. Do not overthink the structure. Don't overthink the format. Just get your ideas down. Agents are really good at formatting this. You can also use voice prompts like you've seen me do a bunch, and then you can refine and add detail later as you test and learn and try different approaches. The really cool thing is you don't actually need to know how to code at all. You just need to know how to explain what it is that you want, which I think is a far more achievable skill. This is a real prompt from a lead generation system that I just built. I said, hey, scrape leads from Appify based on the industry and location I specify, then verify 80% match my target market before doing the full scrape. When you're done, enrich missing emails using a secondary service like any mail finder, then add everything to a shareable Google Sheet and send me the link. Pretty straightforward and pretty simple, huh? All right, let me show you a practical demo. All right, let's build another agentic workflow together. This one I want to be a lead generation or lead scraping workflow. You guys might have seen me build these sorts of things before on my channel. I love building them because they are so high leverage relative to what I used to have to do back in the day. So I figured I'd just bring you guys alongside me for one of the new lead scraping workflows that I'm going to put together. So the first thing I'm going to do, just like I always do, is I'm going to give it in natural language a set of instructions to Claude. I'm using a voice transcription tool, so I'll say, hey, I'd like to build a lead generation workflow that scrapes publicly available information to get me a list of B2B leads. What are the 3 best approaches for this? Now, I kind of know what I want to do here, but I want to show you guys how you can use an agent not only as some builder, but also as something to assist you with the ideation. So what this is saying is we could start by using a LinkedIn Sales Navigator or similar tools to identify decision makers by title, industry, company size, then enrich with contact data via APIs. That sounds pretty good to me, so I'm going to need some additional tool. That's okay. Let's go with the first. I think I've heard of a few different tools we could use to do this. Phantom Buster is one. There's another one called Vane. Which do you think is best for our approach? How should we go about this exactly? So it's now going through and it's performing a bunch of research on these tools. Okay, now it's gone through, performed a bunch of research on all of the tools that we could use, and it's since recommended me a pipeline. So that sounds awesome. I really like this. Why don't I say, let's do it? Yes, I already have a Sales Navigator subscription. Let's do it. Build out a pipeline. I also already have a pre-existing subscription to any mail finder, which is an enrichment tool. So why don't we use that as part of our flow? I want you to build this using the Doe framework. Let me know if you need anything. So now what we've done is we've basically taken our demand, or our request, I should say, and then we've pared it down into a much higher probability build path, just based off a couple of back and forth questions. If you think about it, the total amount of time that it takes an agent to build something is pretty short, all things considered, but it's still like 5 or 10 or 15 minutes. If you screw up and you go down the wrong path, in order for you to walk back and start fresh, you're probably going to have to spend another 10 or 15 minutes in order to have the agent rebuild the next thing. And so, at a very high level, giving it a tiny bit of input initially is super powerful, and it's also a big time saver. So I usually recommend going back and forth at least a little bit while it does its searches, and use your own human knowledge really to pare down the total possible number of paths. So it's going through, building a Google Sheets, LinkedIn lead gen, lead enrichment pipeline, and an email finder client pipeline. All right, once it's almost done all of the scripts, it's going to create a directive just to tie everything together. Do all this for me. Okay, I'm now having it wrap things up. We can now start giving it a test. Obviously, it is one thing if a model tells you that it is good to go. It's a complete other thing whether or not the flow actually works. So we also have to verify that the flow works with a real test. Okay, it's now testing out any mail finder, testing out the Google Sheets connection. Looks like it found an issue with the way that it was going to do the connection. I added a credentials.json file here just from another workspace, which is basically like an OAuth thing. I didn't generate this thing. I had the model generate it for me. It's now going to ask to authenticate for the first time. Anytime you connect to a new Google credential with OAuth, you're going to have to do this. Now I have the browser authentication. I'm just going to pump over here and connect this. This is a great opportunity for me to point out a common issue that people have with agentic workflows. It's where they essentially have the model generate a test case for them. So in this case, that's what's occurring here, test_leads.csv. It then uses the test data essentially to test end-to-end to see whether or not the flow works. That's not good enough because if you think about it, the model just created a bunch of scripts. So the test case that it will come up with is most likely going to be in the same format that all of the rest of the scripts and so on and so forth expect. What's way more informative is for us just to do this entirely based off new data. So that's what I'm going to do next. I don't really want to export the leads from Vane. I instead want you to do all that for me. Okay, and it looks like it now is ready for a test. So I just need to give it a sales marketing or a sales navigator URL anyway, and it'll do everything. Or I could run it myself with one command. That's cool. What I'm going to do is I'll just go back to LinkedIn Sales Nav here, and I have a link. Basically what happens on LinkedIn when you want to find something, like a list of people, is you need to generate a search on the left-hand side. Then you just need to copy over the URL and then just paste it in. So I'm just going to paste this in and I'm just going to see what happens. We'll just test it end to end. All right, now it has found 231 prospects. So it's going to go through and scrape the 231 profiles via Vane, then enrich with any mail finder before exporting to Google Sheets. Okay, it had some issues with a particular API call to Vane. It's since self-annealed and automatically fixed it all. So it's just continuing down the building process on that first run. Once I have it finished this first run, I'm just going to ask it to do a second run, and I'm going to do it completely from scratch. So it's going to be like a cold start. I'm going to instantiate a fresh Claude instance, one that has no idea what the heck's going on, and then we'll see how it goes. Okay, one of the outputs was buffered. That just means that basically it was in a loop repeating. So I just paused it and said, how are we doing? Looks like it's still running, so Python is buffering the output. We're just going to wait for the completion. Sometimes some of these tool calls can take a fair bit, and that's what's happening with any mail finder. The reason why this is actually good for us is because I get to show you guys later on what it looks like to optimize a workflow. Realistically, and I know this because I've done a fair amount of enrichment at this point, you do not need to take this long to enrich 200 records. You could probably enrich 200 records in maybe like 15 seconds or so through bulk requests. The first time that a agent ever builds a workflow, it's going to do so in as simple a way as humanly possible, typically through serial requests, which just means that it's sending one request at a time, waiting until the request is done, then sending another request after that. But what you can do with a lot of workflows is you can parallelize them, which means you could actually send 200 requests simultaneously and then wait for the outputs of all 200 in the same time block as opposed to, independently. So I'm still going to wait for this thing to finish because I want this test to be done end to end at least once. After that, we're going to look into ways to make this faster through parallelization and so on and so forth. Okay, so I got a little bit bored and I just said, hey, could we make this way faster? It's since offered to batch all of these requests, so that's what it's going to do next. And let's see how quickly it performs. While I'm doing that, let me just create a new search. Maybe instead of United States residents, I want to search Canadian residents. That way we'll be able to split test this very quickly and easily. As you can see here, we have 31 results. Maybe we'll also do posted on LinkedIn, so maybe 45 or something like that. Okay, no, it's just 20. If I deselect this, how many do we get? 683? Too many. Why don't we just do Vancouver instead? I want like between 50 to 100. Okay, 66, that's perfect. So this is going to be the URL I use to test the Totally Fresh app. It's now just going to go through the process of self-annealing, running, testing, and so on and so forth. Looks like it found 139 valid emails of my 231 sent. Now it's just going through and updating the script a couple more times. Cool, it's gone through and since found me a bunch of leads, I can open up the spreadsheet to get 159 rows. So these are all of the records with email addresses. There were more records that didn't have email addresses, but we just left those out. Obviously, this is pretty solid, but I want to, number one, make sure that we're documenting this. So I'm going to head back over here and I'll say, make sure to document all changes, both directives and executions. Once it's done with the documentation, I'm then going to open up a totally new fresh instance and then go through and then update and then test. Cool, and it looks like it did some updating. That's pretty solid. What I'm going to do next is I'm just going to open up a new instance of Cloud Code. I'm going to set it to bypass permissions, and I'll say, hey, here's a search URL. Scrape these using our pipeline. All right, so now this is a totally new, fresh Cloud Code instance. Let's see how it performs. It's going to start by thinking. It's checking the directive for LinkedIn scraping, which is great. That's what we wanted. It's then going through here. URL is a sales navigator search, has a bunch of information here. It's going to check how many leads are available. Cool, found 66 prospects. It is now going to perform the full scrape. Okay, and it looks like we got 45 out of those 66. So this did work on a totally fresh list. Took me about 4 minutes. I got a little bit overeager and I was like, hey, are you done yet? But realistically, this works pretty well. So, I mean, a couple of different approaches that I could take here, obviously. I could make this better, make this faster. I could set up approaches to dump all this into a Google Sheet instantly using bulk. I could do a lot of stuff, and that's what I want to talk about next. But for the purposes of this demonstration, this is good to go. We have essentially created a workflow to completely or almost completely automate the entire process of scraping LinkedIn. Obviously, there is still one manual step, which is we need to provide the LinkedIn Sales Navigator URL, but that's something that we could reasonably automate if we'd like to as well. So here's what you don't need to specify. You don't need to know which APIs to use or how they authenticate. You also don't need to know how to structure the code or handle an error case yourself. And you don't even need to know any Python, any JavaScript, or any programming language. The agent's whole job is to abstract that complexity away from you and turn it into a natural language. A really cool hack that I'm using a lot more of now is I don't just have the agent solve it in one approach. I actually have the agent produce 3 approaches simultaneously. Then I either pick one of the 3, whichever one makes the most sense, or, this is kind of neat, I have parallel instances of my agent generate all 3 directive and execution scripts based off of each approach. I then just test their outputs and I rate. I test them on things like how fast it is, test them on things like how reliable it is, and how cheap it is, and then I just pick the best performing one, and then that's it. Why 3 approaches? Well, if you think about it, the cost of exploring multiple approaches is basically free. It's not free. Tokens are not free yet, but they are very cheap compared to the cost of intelligence. And it's also a big chunk of the search space. Basically, if this is like the amount of space you have to search through in order to come up with your really, really cool problem, rather than have your agent just go like manually one by one by one by one and just kind of do this whole thing on its own, you can actually just like quarter this, and in my case I said 3, but you could totally have it 4 and then just have like 4 agents independently simultaneously. I can't draw simultaneous executions here, but just assume that it is. Explore that search space in like a 1/10 of the time. When you do this, I recommend you have it run in a temporary folder. So you say, hey, do this in a temporary folder. Don't do this in the main directive execution framework, because I'm actually giving this to a few of your brother and sister agents to run simultaneously to figure out the best approach. There are a couple of trade-offs with every single way that you build. The first is speed versus cost. So do you need it fast or do you need it cheap? Obviously, we're looking for situations where we have both, but a lot of the time you have to make trade-offs. Next is reliability and complexity. The simple solutions do break less often. If you can store things in one execution script, it's way faster and better than if you store things in 10. The next is breadth versus depth. So if you cover more ground or go really, really, really deep on a few items, it's going to depend, or it's going to change how your agent constructs things. And then finally, sometimes you just need human judgment to weigh these things. So I would recommend at least asking your agent, how would you do this stuff before you actually have it go and build every approach? If you think about it logically, this steering is the highest return on investment time that you will ever spend across your entire agentic workflow career. And the reason why is really some of what I talked about earlier. If you just look at any process that has variability in its outputs, okay, this variability grows over time as you proceed through the process, just because there are more and more and more and more steps possible, right? And so right now, this is kind of like the range of all of the possible decisions that the model could make. Well, if you think about it, the one thing that you have the power to do at the very, very beginning is you have the power to steer what direction this thing goes. And so let's say, hypothetically, my goal is over here, right? Or maybe we should say my goal is over here. If at the very beginning, literally from the first step, the model is already in the wrong direction, it doesn't really matter how much time and energy it takes to build things, right? But if you could just reorient this approach down over here, then your solution is actually in the range of all possible outcomes. I call this steering, just like steering a car. If you steer it, let's say you're going on like a real straight line track and your car at the very beginning of the track is already starting to veer off a little bit. Obviously, the most important thing you can do as a driver is you could just steer it so that it goes basically as straight down the middle of this thing as humanly possible, right? And that's just ultimately something that really takes like a minute or two. I wouldn't recommend trying to outsource everything to the model, like the thinking itself. The first version of anything you build probably will not be perfect, and the first versions of a lot of the things that I build do suck, but that's okay. That's actually one of the points. Doe really depends on iteration, so just run the workflow a few times, watch what happens, open up the reasoning loop, and then just take some notes on what's slow. Hey, I don't really like this. Hey, this takes forever. Is that necessary? Hey, I don't like how this had to call this API. Hey, this is a little too expensive. How can we do it cheaper? Right? Actually, just tell the model what it is. Like, it's not, you're not going to hurt its feelings. It's the form of intelligence that none of us can really quantify. Don't anthropomorphize the damn thing. What'll happen is the agent will diagnose the problem and then implement a fix. And ideally, assuming that you have it in your system prompt, it'll also update both the execution script and your directive, which means next time you run from a fresh instance, it will already know the solution. And that's typically what I recommend. I recommend running it, fixing it, getting in that testing loop over and over and over again. And when you really want to verify that this thing works, you just open it up in a new instance and then have it run. Every problem that you encounter will make your system stronger if you're smart. Edge cases will get handled that you never anticipated. And after a few iterations, you will have a robust workflow that I've heard a lot of people say this term battle tested. I think battle tested is about as real and as accurate a way to describe it. But you'll have something that has actually just kind of like been there, done that. It has seen all possible instances of the problem because it's run 10 or 20 times. It sort of knows what to expect. You basically go from a workflow that the very first time it runs maybe is 80% reliable to one that's 90% reliable, to one that's 95% reliable, to one that's 97% reliable, to one that's 98% reliable, and so on and so on and so on and so forth until it's like 99.25% or something. And maybe this is the theoretical limit that you reach. All right, let's build a lead gen flow start to finish using everything that I've talked about so far. You remember how earlier we created a lead generation workflow? Well, what if instead of just using one Claude instance to generate it, we use multiple Claude instances to generate the lead generation workflow in parallel? Not only would we be able to generate higher quality lead generation workflows, we'd be able to create things that are most likely better because we are able to search more opportunities and options. If that doesn't make sense to you, I'm just going to copy and paste the same thing that I pasted in here. Instead of 3 best approaches, I'll say 5 best approaches. I'll say be comprehensive and give me all possible options. And then instead of publicly available information, I'll say HVAC companies in Texas to get me a list of B2B leads and their emails. Okay, great. Once I give this parent agent some room to think, what I'm going to do is I'm then going to open up a bunch of additional Claude Code instances. So new. So we're going to have 5 in total. What I'm going to do is I'm just going to set things up so we could see them all. Next, I'm going to provide some scaffolding. So I'm just going to say, hey, your task is to build a lead generation workflow according to the below details. I'm giving similar tasks to 5 other agents. Since you're operating the same workspace, to minimize the probability of a conflict, do all your work in a new tmp/test3 folder. And then what I'm going to do is I'm just going to feed in all of this. So I'm going to say, boom, 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 and then boom. And now I'm actually just going to run all of these simultaneously. What's cool is this is going to create new folders inside of this TMP, which are not going to interfere with our other directives and our execution scripts. I can now remove this top level script here for simplicity. And now it's going to go through and just create all of these. Not all of these are at the exact same level, obviously, but this test2 directory structure and the test4, when they get created, they're going to just do their work in there. So in this way, I'm capable of exploring a large number of options in a very short period of time. I mean, obviously, I can take a brief high-level look at like one of these things and say, okay, this one is most likely the highest probability of working. But it's much easier if I just explore them. And then what I do is anytime I run into a hiccup with one of these flows, I just take a look at what the hiccup is. And if the hiccup is like so big that it would be a pain in my ass to deal with, then I just drop that and then I don't continue. Then for the survivors, once I have like a pretty good looking workflow, I'll test them all side by side, ask them to go do a scrape. And then once I've done the scrape, I can just compare and contrast results. What's really sweet is when all these things are done, I can sometimes combine the best of each. And then I could say, hey, build a unified lead generation workflow that combines the best of X, Y, and Z. And then it'll, find 30% of leads with one approach, 30% of leads with the other approach, 30% of leads with the third approach, and so on and so forth. Anecdotally, it feels really cool to be able to manage and orchestrate this many simultaneous builders. I don't usually do 5 at a time, but I just wanted to demonstrate that you can explore a very large search space in a very short period of time. So after a few minutes, these are now beginning to finish. The one on the left-hand side has tested the pipeline with a full batch. Just going to take a peek. See, we've now generated 4 of these files. We then have our pipeline summary, and now we just need to enter some API keys, essentially. Now, the issue is I've yet to give it a Google Places API key or a Hunter API key, so I'll just say, could you set up the Google API key for me? I don't have Hunter, but I do have an email finder. Please do this instead. Over here, Apollo. Okay, and then one of these wanted a sales navigator URL for HVAC companies. So I'm just going to go HVAC and then geography. Why don't we just go Texas? Because I think that's what that was. The rest of this looks pretty reasonable. It's 4,000 results. I just want a really, really like simple one. So I'm just going to go change jobs 54. That way we should only get 54. Go back here and then I'll feed in the URL. I then see an Apollo API key. Yes, Apollo API key. It's then going to go through and give me instructions on one of my API keys. So I'm going to head over here to Google Places API. What I want is the Places API new, apparently. So I'm going to enable this. And now it's just a process of getting API keys for everything, really. Copying the API key, just going to paste that in there. This is now testing. This is going to test. This is now testing. And then we just have these 2 over here, which are in the process of building. This here ran into an issue with one of the scrapers, so it's decided to pivot and then use an Appify API token. That's cool. I don't mind that. This here on the left is now doing some debugging and so on and so forth. That's okay. I don't need to be a part of this. All I'm doing is I'm just overseeing, and if any one of these workers needs me for anything, I'll provide it. All right, and we are just testing across the board. We got 50 leads running for most of these tests. Some of them are 10. That's okay. I'm seeing this task over here is running into some issues, namely the Apollo API key that I provided earlier was for a totally free account. So it doesn't look like it can actually go and enrich them. This one here on the left looks like it's pretty solid. So it's since found a verified email address. That's pretty cool. I did no work here. I just let it run. This over here is doing a batch email scrape. And this right over here is now running a pipeline test with a fixed client. I've actually forgotten what's going on over here on the left, so I'll say, describe what is occurring top to bottom. So this is scraping the Google Places API for terms like HVAC contractors, heating contractors. It's going across 50 Texan cities. Then it gives me a big list of leads. It's then enriching with emails before exporting to Google Sheets. So that's pretty cool. Let's run this on a test of 50. Meanwhile, over here on the right, we did run it on the test of 50, and it looks like we ended up with 26 email addresses. That's pretty badass. I should note that not all of these are valid. I'm seeing here, one of them is for somebody that works at Neuralink. So probability of that being a valid lead is kind of off. I'm going to want to double check that. So I'm going to go back here and I'll say, I noticed one of the leads was for Neuralink. How are these filters? Are they super accurate? Make sure to double check. Meanwhile, this one over here on the left-hand side is doing some enrichment. This is now actually testing to see how many of these leads are HVAC related. So we're seeing a bunch of these are HVAC related, a bunch of these are not HVAC related. So the search that we're going to be providing here is presumably going to have to be a little bit more specific. I can't just head over to LinkedIn Sales Nav, copy and paste something with the term HVAC and then have it work 100% of the time. Okay, on the right-hand side, this is now giving me some high-level instructions on how I can, do the search better. So that's nice. HVAC and refrigeration equipment manufacturing. Why don't I actually go ahead and just do this? So I'm going to remove this keyword, HVAC. And what I want to do is click Industry, go down here. I see HVAC right over there. I'm going to include that. This is 341 results. Then I'm just going to copy this and paste this back in. Let's run a test on 50. Cool. Looks like this lead flow here worked really well. 18 out of 20 businesses had websites, 13 out of 20 had emails. Meanwhile, we happen to get Satya Nadella, the CEO of Microsoft's email over here. That's always fun. Okay, cool. And now we have a whole list of steps right over here in the middle. So that's awesome. Gives me a brief description of what's going on. And yeah, I like this. So why don't I actually see a result? Where are the leads? Looks like it's going to find me the leads, Texas businesses with emails, and then it has them all over here. This is cool. So hopefully it's clear at this point. I could do pretty much whatever I wanted, right? And we've actually gone through and explored a tremendous amount of search space in a very short period of time. I could, for instance, just send the same message to all 5. Hey, show me the results in a Google Sheet. I could then standardize the test and just ask all of them to do 20 leads simultaneously. And then I could just have them really quickly test to see which one delivers me the highest degree of accuracy on the leads. I could also disqualify a couple. Don't really like this one. It's working. It just found me 3 with verified emails. But I'm seeing that it's using an Apollo endpoint, which isn't 100% right. It's kind of crazy because we're not supposed to be able to use Apollo in this way. We should be having to pay a fair amount of money. And, I think there are a lot of things that realistically anybody could do. You could also just use all 5 of these. But yeah, just wanted to show you guys what that looks like. So what I'm going to do is I'm just going to pretend that I've now selected 3. And I'm going to say, excellent. Turn this into directives or merge these directives executions with the main branch, your approach 1. Then update everything to ensure that the file paths etc are correct. That's actually really cool. I wasn't expecting this to do anything with Apollo. I fed it in my API key, which is free, but yeah, normally they don't allow you to see any of that. And finally, it ended up finishing, and it's since merged my directives with the main directives folder. So I actually have the Texas SOS lead gen directly here. What I could do now is I could test it, I could rerun it, I could optimize it by just asking it to do things faster and faster and faster. And yeah, I was able to accurately assess that this is the flow that I wanted in light of 5 other ones. Total cost to this was no more time than it would have taken me to do the first. Sure, I did spend some of my, in this case, Claude Max Plan usage, although keep in mind that we're talking cents on the dollar here. I also spent a few dollars on Google Places API. I would have spent a few dollars over here. I spent a few HTTP calls over here, and then, some Appify tokens over here. Realistically, though, this allows you to do 5x the tests for just a couple of dollars per workflow build, way cheaper than anything that N8N, Make.com, or Zapier would have charged you just for development and testing costs alone. And we get to do it through self-annealing and have a very robust, reliable workflow to boot.